All right, welcome to the second part of tonight's lesson. I'll try to keep this under 10 minutes. So let's go ahead, let's get this equation. Notice it's not a quadratic, it's a cubic, into our calculator. I'm going to go ahead and hit 3x to the third power. You can actually get the cube if you hit math and go to 3, but let's actually just leave it like this. Minus 4x squared minus 20x plus 9. All right. I'm going to go ahead, I'm going to go back to that standard window, see what I see. So I'm going to go to zoom. I'm going to go down to 6, standard. You actually can just hit 6 if you want. And we're going to notice something start to take shape. It looks like I probably need to see some more in the y max direction and y min. And maybe I see a little bit too much again of this x max and min. So let's go in here. Our x minimum, let's change it to -5. Our x maximum, let's make it 5. And let's pull down that x minimum. Let's try -25, see how that works for us. And an x max of 25. Let's go ahead and hit graph, see if this gives us a better shape. Alright, now I'm starting to see this. Now, I want you to keep in mind, we said, again, this represented the number of solutions. Well, if you look at this graph, it hits 1, 2, 3 times, which means we actually have 3 real solutions. If they were imaginary, they would not be x-intercepts. Alright, so we can talk about a couple things here. Intervals of increasing. Well, I don't want to calculate this exact point just now. I can see that my graph is increasing along this interval until it reaches this relative maximum. Alright, from this maximum down to this relative minimum, I'm decreasing, and again I begin increasing again from this relative minimum. It looks out here to infinity. Okay, so that's again increasing and decreasing intervals. We've talked about that in the last unit. And although this seems like a maximum, it's only a relative maximum because this graph actually continues on infinitely in that direction and infinitely in this direction. So a maximum, another maximum would occur up here, although infinity never ends. And we're going to call this point a relative minimum. Again, it's not the lowest the graph gets, but in this area relative to what's around it, it's a minimum. More specifically, we're going to call these turning points. Okay, when the graph goes from increasing to decreasing, this is a turning point. The graph here goes from decreasing to increasing. Again, we have another turning point. So let's use our calculator to calculate those turning points by calculating minimums and maximums. Okay, so go ahead, hit second calc. We're going to calculate this one first on the left, which appears to be a relative maximum. Go ahead, hit enter. Now, it kind of bothers me that I can't see this up here, so let's actually go to our window one more time. Let's increase our y max to maybe 35. Let's go a little higher. Let's make it 40. Hit graph. Now I'm going to be able to see a little more of that when I get that cursor on the screen. So again, second calc. Let's go down to maximum. Alright, I'm going to go left bound of that relative maximum or turning point. Hit enter once. It asks me right bound. Hit enter again. Hit enter a third time. And I get that relative max to be about -1.1, comma, 22.17. 22.17. I want you to take a second right now, and I want you to calculate the other turning point, which is a minimum, and I want you to compare that answer with your partner tomorrow. All right. Now, I know we can't be sure, because we haven't studied this before, what the behavior of this graph is off in this other direction. But it does actually go infinitely this way and infinitely negative in the y direction over here and in the x direction. So I want to introduce you to a concept called limits. Alright, and limits are just talking about the end behavior of my graph. So limits are actually the start of a calculus concept, so it's kind of cool to see it at this level. This says the limit as x approaches infinity means what's happening to my y values. Alright, well let's look at this graph. As my x values approach infinity, as my graph goes out this way, I'm getting wider and wider and wider. My y values will be going up, 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 and up. So as the limit as x approaches infinity would be infinity. Alright, now let's check this in the other direction. The limit as x approaches infinity, or sorry, We just did that one. Let's go negative infinity. So as my graph, as the x values go out to negative infinity, what's happening to my y values? Well, it seems like my y values again are going down to negative infinity. All right, we'll check all kinds of behaviors here with limits, but that's just kind of a little intro. All right, total number of zeros. Well, when I look at this, I can see there'll be 3. I wasn't sure before if they would be real or complex, but since I can see 3 clear x-intercepts, I have 3 real zeros, and in this case, I would have 0 complex zeros. Let's try one more and we'll call it a day. All right, let's get out our calculator. Let's clear out our y equals, and let's put this last one in. Let's actually take some guesses here about what's going on. It looks like I'm going to have a total of 4 zeros. All right, let's graph this. So I get x to the 4th minus 3x squared plus 5. Go ahead, hit graph. I'm going to still be on that window from the last problem. Seems like it works okay. All right, now this is a little harder to see, but it seems like I have a decreasing interval. Let's actually, what happened here? 3x to the 4th minus 2x squared. Oops, I forgot my 5x. All right, let's put that in there. Now we're going to see something different. There we go. All right, seems like I'm decreasing along this yellow interval, and I have a turning point that occurs here. I start increasing again, and I never stop increasing over there. Alright, so I only actually have one turning point that occurs here, so let's take a second, let's calculate that. It looks like a relative minimum. Actually, that's an absolute minimum. So let's go ahead and hit second calculate. Second calculate, I'm going to go down to minimum, hit enter. I'm going to go left bound of that minimum, hit enter. I went kind of far left bound there. See if you get the same answer as me. Hit enter again, enter a third time. Alright, and I get my turning point to be about negative 1.5, comma, negative 1.5, comma, negative 9.2. Alright, next, I'm going to go ahead and I'm going to check the limits, or my end behavior. So I'm going to check the limit as x approaches infinity. And I'm also going to check the limit as x approaches negative infinity. So let's check this out. Again, my graph goes on infinitely here. So this is saying as my x's approach infinity, what's happening to my y's? Well, it looks like my y's are also increasing up to infinity. So the limit as x approaches infinity would mean my y values also approach infinity. Right, on the flip side, the next is asking as x approaches negative infinity. In other words, as the x values go out to negative infinity, what happens to my y values? Well, in this case, it looks like they also are approaching infinity on this side. So in this case, instead of negative infinity, like the last problem, we get infinity. All right. If I were to calculate the number of real zeros, the real zeros are the x-intercepts. Right? Well, it looks like in this case I have one x-intercept, 2 x-intercepts. However, there's a total of 4 zeros, which means 2 of my zeros must be complex because I cannot see them on the graph. We don't know how to solve that yet, but we will next week. Have a great day. Good luck in class with your partner. Work hard, and I'll see you all on Monday.